Hey everybody, this is a lesson for my grade 10 MIAP class. Just making sure my sound's good here. We're going to pick up right where we left off after the word problems with the last kind of new lesson in our Systems of Equations book. And I've pointed out to you many times, I think, that this actual chapter might be the most important chapter. So important that it's now blurry. Come on, would you stop that? There we go. This is probably the most important chapter in the course if what you're doing next year is moving on to pre-calculus math, because the algebra skills here that we need are just essential for your ability to be successful in that program. And what we're doing today is we're going to be adding fractions into the mix of your algebra. And I get all kinds of people go, oh, I don't know, I don't remember my fraction skills from junior high. Fix that. There is no two ways about it. A calculator with a fraction button, I know most of you have one, isn't going to help you in pre-calculus for two reasons. Number one, we don't usually let you use a calculator. And number two, you have to understand the actual mechanics and the algorithms of working with fractions, because you're going to be doing algebra where there is, or you're going to be doing fractions where there's algebra in the fractions. So it gets harder than this next year, so this is where we have to kind of make sure we understand how fractions work and how they behave. And the first two questions don't even look like they have fractions, but we'll fix that. First, let's look at what it says. It says solve the system here in example 1. And you know what I noticed? I noticed that if this was a 2, those would just cancel when I add them. So I'm timesing this equation by 2. I'm leaving this equation alone. And 2x's is, of course, 2x, 2y's is 2y, and 2 times 1 is 2. And now I can add those together. That cancels, which is why we did it. 4y is what you get when you add 2y plus 2y, and negative 4 plus 2 is negative 2, and now you can see where the fractions are going to come in. The next step to solving this is to divide both sides by 4, and look at that. Now, if you leave it like that, you're in trouble, because that is not the most simplified way you can give me the fraction. That is negative 1/2. So now I'm going to take that 1/2 and put it into this equation to figure out what x is. And then I might rewrite that more simply. Plus minus doesn't mean much. Then I'm going to add 1 to both sides of the equation. Now, some of you, I noticed on the last test, like to give me answers in mixed numbers. I don't want mixed numbers. You're right if you're thinking, well, 1 plus 1/2 is 1.5. But that's not a particularly useful number in coordinate geometry and in most branches of algebra, especially when we're dealing with things like slopes, where we actually like a fraction that's a rise over a run. These aren't slopes, they're coordinates, but it's still more useful for most people to look at an answer as a simplified but improper fraction. So if you don't remember how to change these into these, it's 1 times 2 plus 1. That's where I get the 3 from. And that gives me an answer of 3/2 for x, and negative 1/2 for y. And as always, I like to do a check to see if I did this right. So I used this equation to get that, so I'll use the first equation. So negative 2 times 3/2 plus 2 times negative 1/2 equals negative 4. When you times a denominator by a numerator and they're the same, they cancel. And that would be negative 1, and that is true. Negative 3 plus negative 1 is 4. I know we got the right answer. Okay, the next one's going to be the same. It's going to turn out to be fractions, and it's going to be even uglier numbers. But my favorite thing about math is that the rules don't change because the numbers got ugly. In fact, I'm going to get creative on this one. You know what I notice is that these both have a 4y in them. I could just subtract the equations right now, but just for fun, I'll do this one by the other way. I'll do this by substitution. I will add 2x to both sides. And then I will replace the 4y in this equation with 2x minus 20. And that equals 8. Right? X plus 4y equals 8, and that's 4y. So x plus 2x is 3x. I'll add 20 to both sides to save some time. Now, does 28 divide by 3 evenly? Or whole? Nope. And that doesn't simplify, because 3 doesn't go into 28. It goes into 27 and 30. Now I got to figure out what y is. I'll just plug it in here. 4y is equal to 2 times 28 thirds minus 20, right? So 4y is equal to 2/28, which is 56 thirds. Now, what do I do with 20 over 1? How many thirds is that? Well, 1 is 3 thirds, so 20 is 60 thirds. So 4y is equal to negative 4 thirds. And I have to divide both sides of the equation by 4, but when I'm in fractions, instead of dividing, why don't I just times by the reciprocal? And look at that. That cancels the 4's. Y is equal to negative 1/3. So I got an answer. 28 thirds, negative 1/3. Okay. And let's see. What do we do from there? Well, I'm going to do a check, as I usually do. And since I use this equation the most, I'll kind of switch back to that one. So 28 thirds plus 4 times 1/3, negative 1/3, sorry, has to equal 8. So let's see. 28 thirds minus 4 thirds has to equal 8, and that's what it does. 24 thirds is in fact 8, because 24 divided by 3 is 8. Yep, we got it. So there's examples of questions that don't have fractions to start with, but they end up having fractions at the end. Now let's try this out. Examples 3 and 4. Ignore that stuff at the bottom for now. We're going to get to that in a minute. Solve this system, and now we're starting with fractions. And I don't know about you, but if I can avoid having to deal with fractions, I will. So what number could I times this equation? I'll start with the second one. What could I times that equation by that would make all those fractions go away? Yep, I'm going to times everything in the equation by 7. So that's going to be 1x minus 1y equals 1. Boy, that's simplified real nice. Now, what if I times this equation by 7? Well, it would cancel this 7, but it wouldn't cancel these 3's. What if I times everything by 3? It would cancel the 3's, it wouldn't cancel the 7. So I'm going to times everything by 21, right? Which is the lowest common denominator. That's going to leave me 7x plus 6y, because think about why that is, right? 7 goes into 21 3 times. 3 times 2. 3 goes into 21 7 times. 7 times 1. And then on the other side of the equal sign, 3 goes into 21 7 times. And then I have to do 7 times 14. Okay, 7 tens is 70. 70 plus 4 more 7s, 28. 70 plus 28, I think that's 98. You can check my mental math on that, but I think I got it. All right, now I think I'll use the elimination method. I think I'll times this equation by 6. So that's going to be, I'll leave the first one alone. 7x plus 6y equals 98. And then I'm going to multiply this equation by 6. So that's going to be 6x minus 6y equals 6. I can add these equations now, and it eliminates the y's. So I have 13x's equals, when I add those, I get 104. And I think 104 might divide by 13. Let's count. Let's skip count by 13, shall we? 13. I'm counting on my fingers. I'm not above counting on my fingers. You can see in the shadow I'm counting on my fingers. 13, 26, 39, 52. Stop. That is double 52, and I've counted to 4, so that would be 8 13s. Feel free to use scrap paper if you don't feel like counting on your fingers. Now, but don't grab a calculator. You are not allowed a calculator for these kind of things. All right, now where do I get the answer? Oh, right here. There's where I can get my y answer from. It's the simplest equation here. So I'm going to have minus 8 from both sides and divide both sides by -1. And isn't that interesting? So this is kind of the opposite of the first questions. Examples 1 and 2 started without fractions and ended up with x's and y's that were fractions. This one starts out with fractions for coefficients and constants, but the variables end up being whole numbers. Isn't that cool? And I might want to do a check on this too. So let's do a check. I'll use the first equation. 1/3 of 8 plus 2/7 of 7 had better equal 14 thirds. Okay? Those 7's cancel, so that's 2. This is 8 thirds plus 2 is 6 thirds. And yep, 8 plus 6 is 14. Winner. Okay, let's do the one on the other side. Once again, just to mix things up, make it fun, I might do this one differently. Just to show you that, you know what, you can do these differently. Like, for example, you know what I notice? I notice that, once again, I have this term and this term the same. I have a couple things I could do. I could subtract both equations, or subtract this equation from that one. That would cancel the 1/4. But then I'd have to deal with subtracting these fractions. I don't know if I want to do that. I think what I will do instead is use the substitution method. I think I'll add x to both sides of this equation, so that 1/4 y is equal to x plus 3/2. Then I'm going to replace this 1/4 y with x plus 3/2. And then there we go. Now I'll get rid of the fractions. What one number could I times all 4 of these things by, and it would eliminate all 3 of those denominators? Well, in other words, what's the lowest common denominator of 2, 3, and 6? The right answer is 6. So 6 times x is 6x. 6 times 3/2 is 9. 6 times 1/6 is 1. Don't forget the x. And 6 times 1/3 is 2. Okay? Again, use scrap paper if you need to when you're doing that, but do not reach for your calculator. 6x's plus 1x is 7x's, minus 9 from both sides, and hey, it's happening again. I got an integer. If I go right to here, I'll get my y answer the fastest. 1/4 of y is equal to -1 plus 3/2. I'm going to minus 1 from 3/2. 1 is, of course, 2/2, so that's 2/2 taken away from 3/2, which is 1/2. And then how do you divide a half by a quarter? Well, you can do that by just doing the opposite. You can times both sides of the equation by 4, so that's 1/2 of 4, which is 2. So my answer is -1, 2. I won't bother checking that. I'm very, very sure that it's right. I could even almost do it mentally. Go to this equation here, 1/4, so that's -1/4 plus 1/3. So that's basic. Oh, wait a minute. Hang on. Maybe I have done this wrong. Oh, I did it backwards. Sorry, the x is negative. So let's do that again. X is -1, so that's -1/6 plus 1/2. And yes, if I take 1/6 away from 1/2, I know that's 1/3. So yeah, we got the right answer. Now, I did this kind of my own sort of stylized way. I've been doing algebra for 30-something years. I've got a lot of experience, and I saw little tricks like, oh yeah, I noticed that I can use substitution easily, and I'm good at finding common denominators. You don't have to do things exactly the way I do them. You just have to end up at this right answer using algebra, showing your work, and not touching a calculator. So feel free to try this question and see if you get the same answer as me doing it a slightly different way. Subtract these equations from each other. Try multiplying this equation by 4 and this equation by 12, then working with them when there's no fractions. See if you come up with the same answer as me. See if you can freeze the screen like I just did because my hand's moving too fast. Oh, there we go. We're back. So there we go. There's examples 3 and 4. And we have some room at the bottom. Could we please do an example 5? For all you people missing decimals, going, why are we doing all these fractions? What's wrong with decimals? Well, there's nothing wrong with decimals. They're fine if you're not smart enough and clever enough and skilled enough to handle fractions. Then by all means, yeah, use decimals. No, I'm kidding. Decimals have their uses. Like, for example, here's a word problem. I'll give you. Why don't you pause the video right now and copy it down? I'll read it out loud too. Example 5. Nuri invested $2,000 in 2 different investments. Sorry, I was writing in pen. One with an annual interest rate of 8%, the other with an annual interest rate of 10%. After 1 year, the total interest was $190. How much did Nuri invest in each rate? Okay, pause the video and copy that down. Got it? All right, now, let's solve it. I stole this question right from your textbook, and it's a good example of a question where, yeah, decimals are useful. So let's see. I want a system of equations. I am going to let x equal amount invested at 8% and let y equal amount invested at 10%. This is a really good real world problem because, you know, you don't put all of your money invested in one place. What if that one investment you make is bad? They call this diversifying your portfolio. Nuri here has a portfolio of 2 investments diversified so that if one of them goes belly up, he doesn't lose all his money, right? So, what do I know about X and Y? Well, the amount of money he has to invest in total is $2,000, right? That's my total. So there we go. X plus Y equals 2,000. There's one equation. Now, what's the other equation? Well, think about it. How much interest does he make? He makes 8% of the X that he invested. So how do you say 8% of a number? Any ideas? Yeah, you have to get rid of the percent and turn that into a decimal. And then what do you do with the Y? Well, 10% of Y is 0.1 Y. And that's going to equal $190. Now, there's my 2 equations. How do I figure out X and Y? What do I do with these decimals? Well, you know what? What did I do with the fractions? I got rid of them. How do I get rid of those decimals? What number could I times this equation by and it would get rid of my decimals? The answer is times it by 100. If you times it by 100, I'll leave this equation alone. If I times it by 100, I get 8x, I get 10y, and I get 190 with 2 zeros on it. Ta-da! Okay, I'm kind of out of room, but I know that the back of this thing is blank, so I'm going to just rewrite this equation. So I've got 8x plus, that's how good my memory is, 10y is equal to 190 with 2 zeros on it. And the other equation was x plus y equals 2,000. What do you want to do? I think I'm going to times this whole equation by -8. So now I'm leaving the first equation alone. And then I have -8x minus 8y equals -16, and then 1, 2, 3 zeros. Add those equations together, and I get 2y's. I get, let's see, 0 minus 0 is 0, 0 minus 0 is 0. Then I have, let's see, those, I didn't write this very good. They should line up. 0 minus 0 is 0. And then 19 minus 16 is 3, right? Yep. And then I'm going to divide both sides of the equation by 2. And I get myself $1,500 for y. Then I'm going to go back to this equation. X plus $1,500 equals $2,000. So x is equal to $500. Therefore, what was this guy's name again? Nuri. Nuri invested $500 at 8% and $1,500 at, what was it again? 10%. All right. Your homework has questions just like the 5 we just did, and practice hard, and that assignment will take us into next week. Enjoy your long weekend, guys.